This video is especially for JP boys, Satvana boys facing issues in ionic equilibrium. So it is a quick revision type of video. Okay. Now focus on the board. JP Satvana. Okay. So basically, I am assuming that you know what is acid, what is base. Quickly revising you: strong acid, strong base, salts. Okay, and four category of salts. So acid, two category: strong acid, weak acid, again base, two category: strong base, weak base. Third is salt, no category, salt. Few things to remember: salts, star mark. What is the meaning of star mark? I will explain. Completely soluble, sparingly soluble, sparingly soluble, soluble. Completely soluble, solubility is greater than 10 to the power minus 3 molar. Here solubility less than 10 to the power minus 3 molar. Okay, but there is a catch. Caution is there. Caution is there. What caution is there? I will tell you by example. Okay. Two things to remember. First, every salt is strong electrolyte. Every salt is strong electrolyte. Every salt is strong electrolyte. First thing. Second thing, first day halides. First day halides. Second day halides except few fluorides. Few fluorides. Second day halides except few fluorides. First day halides, second day halides except few fluorides, and all nitrates, whatever is the cation. All nitrates, whatever is the cation. All nitrates, whatever is the cation. All nitrates are soluble. Are soluble. Okay. First day halide, second day halide, except few fluorides, and all nitrates are soluble. So whatever is the cation for nitrate, it is immaterial. Every nitrate will be completely soluble. Got it? So this is all about salt. Salt completely soluble. Solubility will be greater than 10 to the power minus 3 molar. Sparingly soluble. The solubility is less than 10 to the power minus 3 molar. Caution. What is the caution? I will tell you once again. So salt, star mark. Caution, star mark. Condition apply. Okay. This condition apply. We will deal when we full-fledged complete the salt. Now come to acid. Acid, strong acid. Remember few acids only: HCl, HBr, HI, HClO4, obviously HiO4. These are strong acid. Okay. H2SO4, again star mark, condition applied. Weak acid, there are so many, but common acid is CH3, COOH, or we can take first example formic acid. Formic acid, then acetic acid, hydrocyanic acid, HCN. There are so many more. Benzoic acid, these you found in problems. Okay. Again, star mark is there, so I put some star mark also here. H2CO3, star mark, that is known as carbonic acid, H2CO3, carbonic acid, star mark. Then we have oxalic acid, H2C2O4, again star mark, right? Then we have category, one more category is there, star mark category, that you commonly found in the problems, numerical problems, H2S, star mark category. Then I will put some acid with hash mark, H3PO4, hash mark, okay, H3PO3, hash mark, H3PO2, hash mark, okay. So star mark is basically I can explain here what is the star mark. Star mark is basically diprotic, they can liberate 2 proton, okay. So every star mark, this is diprotic, this is diprotic, this is diprotic, this is diprotic. What is this blue color hash mark? Blue color hash mark, it is triprotic, triprotic, this is diprotic, and this is monoprotic, monoprotic. So you can also prepare short notes, such type of short notes based on this information, and these are the key information that you have to remember while you are solving the questions of organic chemistry. Okay, I will move aside so that you can easily note down all the things. So chemistry is fun, isn't it? It is our motto. Chemistry is fun. Chemistry is fun. F-U-N, capital. Chemistry is fun. So fun part you are losing. So just wait for the fun part, because it is a serious time. You can see the watch. It is almost 5:15 morning. Hope it is all noted down, or you can freeze the screen. Okay, so this salt part I am erasing now. I think there is no issue. Completely soluble, sparingly soluble. Completely soluble, sparingly soluble, I can explain, but I will explain once again. But every salt is strong electrolyte. Mark this sentence, it is very important. Whatever is the salt, always strong electrolyte. First day halide, second day halide, except few fluoride, and all nitrates are soluble. Whatever is the cation, that is the key points I can recall you once again. Okay, now I am erasing this. So now we have our discussion. Base I will shift now here, this side. So base again 2 category, base again 2 category, strong base, weak base. Okay. So you can recall from the prior information that strong acid means 100% ionized. Okay, we call it approximate 100% ionized, and the thing is K, acid constant, Ka, equilibrium constant for acid constant we call it, is very greater than 1. Got it? What is the meaning of weak acid? Weak acid means partially ionized, acid constant Ka is less than unity. So like this you can identify if constants are given. Otherwise, better to remember these things. They are useful for the JEE main purpose also. Advanced purpose, they generally give the constant. Okay. Main purpose, not mains. Main purpose, we need this key information. Okay. So what is the meaning of strong? What is the meaning of weak? That you have understood. Same meaning I can apply here. Strong base again 100% ionized, weak base partially ionized. Same here, Ka replaced by Kb. Okay. So once again we can call it strong base means 100% ionized. Kb, now we call it base constant. Now we call it base constant. Base constant is basically very greater than 1. Here partially ionized, and base constant Kb is less than unity. Okay, so this is the meaning of strong and weak. Constant is very greater than 1 for strong. For weak, constant Kb will be less than 1. What is the meaning of this constant? I will explain you later. Strong base, you can remember all first A base except lithium. Lithium, actually there is a different story. So lithium you can put condition mark. Okay, so basically it is misunderstood by many faculties also. It is misunderstood by many faculties also. Lithium hydroxide. Again, so condition apply, NaOH, no doubt, strong base. Then remaining member, लीना की रब से फरियाद. Okay, लीना की रब से फरियाद. So potassium, लीना की रब से फरियाद, रब से है ना, फरियाद francium. Francium is basically radioactive. So all NaOH, KOH, RbOH, cesium hydroxide, all will be strong base. So they are 100% ionized. Got it? Then again condition mark on the calcium hydroxide. Condition mark is there. What is the condition? I will tell you. Okay. Weak base is basically ammonia. We have ammonia, NH3 aqueous, or we can call it ammonium hydroxide. Okay, same thing, aqueous, no difference. If 1 molar ammonia is given aqueous in the question, or 1 molar ammonium hydroxide aqueous is given, both are same, they are not different. Okay, when we deal chemical kinetics, I will tell you how this happen. Then we have hydrazine, NH2, single bond NH2, basically 2 lone pairs are there. Okay, and it is also a difficult one for advanced purpose. This is monoproticon. One lone pair is there, so we call them mono. Here we call them monoprotic, or we can call them monobasic. Here we call them monoacidic. Just opposite. Acid, basicity is defined, base, acidity is defined. Means how many H ion acid furnish, okay, and how many OH ion base furnish. Same time, one more definition is there for base, how many proton it can capture. So it can capture only 1 proton, it can capture 2 proton. Okay, but there is an issue. If it will capture a 1 proton, then it will become positive. Got it? Now again proton positive, so positive repulsion will be there. Are you getting me or not? Okay, so condition applied. Then mostly we have amines, RNH2. That is a different story that will be explained in your GOC part. Okay, so R may be any alkyl group, or it may be any aryl group also. Then we have that aniline already included. R may be alkyl or aryl. Okay, also 1 lone pair like this. So most of the time they have amines. Okay, they can give you some another base in the question that we have used in coordination compound. So EN they can use, NH2 lone pair, then CH2, NH2 lone pair. So basically it can capture 1 proton from here, it can capture 1 proton from here. Okay, ethylene diamine. So base, such base you will encounter in the question. So basically here we have a variety of star mark, that is diprotic, then there is a hash mark where triprotic is there, diprotic is there, monoprotic is there. Such variety is only possible here. So what is the condition for this? That it is not completely soluble. So basically it is sparingly soluble. Although it is a strong base, soluble, but it is sparingly soluble. So there is a solubility issue with calcium hydroxide. है ना, and all the star mark I have explained you, this star mark I have explained you, it can capture one proton, then it become positive charge. Here chain length is very large, the chain length is very large, so this end can capture proton, then this end can also capture a proton. Here also it is possible, but the tendency will be very less. Got it? Because itself become small chain, itself become positive charge, so proton capture, second proton capture tendency will be very low. Understood? So note down please quickly. Okay, I am erasing it now. So the basic problem with ionic is that we cannot recognize the species. This is the basic problem. What is salt, what is base, what is acid, which one is strong, which one is weak. These are the basic problems with the kids. So initially we are focusing on the acid part, base part. Okay, so strong acid, strong base I told you already. So star mark on H2SO4 I can explain now. H2SO4, its first ionization. I generally use this symbol for complete dissociation. So H2SO4, I should write equilibrium sign theoretically, but I am not using it. It's my rigidity, you can say, that Ka is very greater than 1. So what is the meaning of Ka is very greater than 1? This, suppose I use equilibrium sign, then what will happen? I can use this equilibrium sign also. Okay, this K is very greater than 1 means this reaction will almost complete in the forward direction. Understood? This reaction is almost complete in forward direction by K is very greater than 1. Got it? If I write second ionization, we call it second ionization. Second ionization, we call it Ka1, first ionization constant. Now second ionization, SO4 2 minus. It is not that much strong. So basically second ionization constant Ka2 is nearly equal to 2 into 10 to the power minus 2. So it could be a problem in advanced, but sometime it could be a problem in main also, because some difficult question may be asked. If they give this constant, then we have to consider it. If this constant is not given, we can neglect this. Okay, it is a very limiting case. Okay, so limiting case always require quadratic equation calculation. I'll explain you how. So C00 second ionization we are considering, because whatever is the concentration here, that concentration will transfer as it is here. Got it or not? Because it is 100% ionized, almost 100% ionized, K is very greater than 1. But then second dissociation, whatever bisulfate we are getting here, that will come as it is, because first step 100% ionized. Now the degree of ionization alpha, we use it degree of ionization, degree of ionization. Okay, so we will call C minus C alpha, C alpha, C alpha. Again there is a issue. What is the issue? They are in same solution. So basically C will be already there. So CHIN will be already there. So now it become what? C plus C alpha. Got it or not? They are present in one solution. Both the equilibrium present in one solution. H2SO4. So this is a very high equilibrium constant, means almost ionized. So from whatever is the concentration H2SO4, you will get HIN as well as bisulfate ion. These HIN will carry as it is, then bisulfate will ionize. Initially it is C from here and it is C from here. Okay, so now this becomes C minus C alpha, C plus C alpha and C alpha. Got it? Now rest is very simple. You can use Ka2. Ka2 is equal to concentration HIN whatever SO4 2 minus and concentration of HSO4 minus. Here approximation cannot be done because Ka value is 10 to the power minus 2. So you have to solve quadratic. I will put simple hint, solve quadratic. Solve quadratic. You will get quadratic equation. So solve it. then you will get the answer. Otherwise your answer will be wrong if this constant is given in main exam itself. Generally it is given in the advanced case, but once it is asked in mains also, main exam also. So be aware of such constants. 10 to the power minus 2, 10 to the power minus 3. Such constants are very risky. If it is minus 4, minus 5, there is no problem. Got it? So one mystery, 1 star mark condition resolved. Now, there is no problem with HCl, HBr, all will be 100% ionized, so no issue. Now consider weak. So weak, we can take general expression HA, any weak acid, it will ionize partially, so equilibrium sign is must. It is any anion. A is what? Any anion. Any anion. Constant is defined Ka, weak acid ionization constant. So initially C 0 0, C minus, C alpha, C alpha, C alpha. Then we can use this Ka is equal to concentration H ion, concentration A minus over concentration C HA. We can put the values C alpha upon C into 1 minus alpha. 1C can be cancelled. So finally it becomes Ka is equal to C alpha square upon 1 minus alpha. This is exact. Basically you have to solve quadratic. Exact expression, no approximation done. So how we do approximation? That is based on Ostwald dilution law. So Ostwald's dilution law that can be proved from here itself. Okay. So if alpha less than equal to 10%, both main as well as advanced, alpha is less than equal to 10%, you can use this approximation provided K is not, I told you, K is not 10 to the power minus 2, K is not 10 to the power minus 3. Okay. So I can write here Ka or Kb, because same derivation we can use for weak base also. Ka or Kb must be less than equal to 10 to the power minus 4. Okay. Ka, Kb must be less than equal to 10 to the power minus 4. Then this approximation is okay, no problem. If it is minus 2, minus 3, be aware, it is a risky case. Okay. So from here what I will get? This expression. From this expression what I do? If alpha is very less than, alpha is less than equal to 10%, so 1 minus alpha is nearly 1. We will neglect alpha as compared to unity. Okay. So we will neglect alpha as compared to unity. Now expression become K is equal to C alpha square. This you can use directly. It is for important formula to be remembered, exact expression. Okay. So from here you will get what? Alpha is equal to root over K by C. But this is approximate. It is not exact. Exact alpha can be calculated by quadratic equation only. I am repeating, exact alpha can be calculated by quadratic equation only. But approximate alpha you can calculate from here and you can justify whether the approximation is valid or not. Understood? Okay. So by knowing this alpha, what I can do, this is the caution thing. So I am just moving here to here. So from this, you know here, from here, H ion. So H ion concentration, because in acid we are interested in H ion concentration. So H ion concentration is equal to what? From this expression here, H ion concentration is C alpha. So C alpha, you can put the approximate value of alpha, root over Ka by C. So H ion becomes root over Ka into C. Okay, this expression you can remember, but it is approximate, not exact. Same thing, 10 to the power minus 3 Ka, Kb 10 to the power minus 3, be aware. Ka 10 to the power minus 3, Ka 10 to the power minus 2, घंटी बजनी चाहिए. The bell must ring in your head that it is a limiting case or risky case. Got it? The similar treatment I can do for the weak base also. Suppose weak base. So weak base we can take weak base say BOH. It will ionize like this, B plus and OH ion. Okay, we call KB base ionization constant. Same thing, initial concentration C is 0, 0, C minus C alpha, C alpha, C alpha. All the expression. Only revision thing will be there. So now you can recall KB exact value will be C alpha square upon 1 minus alpha. This is the exact expression. Now KB is equal to C alpha square, approximate expression. Then alpha definitely you can calculate, same thing. Alpha is basically root over KB by C. And we are interested here in what? OH ion. So OH ion concentration is basically what? Root over KB into C. So it is a quick recap of the weak base. B means any cation. B means any cation. Previously I told you A minus means any anion. So B plus means any cation. Understood? Erasing it. Now come to the diprotic and triprotic thing. Diprotic and triprotic acid. I'll teach you only acid, then base you can extend. Diprotic, suppose take example of H2S. It will be ionized in two steps. First step we call it Ka1, first ionization constant. Second step will be like this, HS minus change to H plus plus S2 minus. The constant will be Ka2. So first ionization constant, second ionization constant. Similarly, if we have triprotic, then there will be three ionization constant. First ionization constant Ka1, second ionization constant Ka2, third ionization constant Ka3. Got it? So here the treatment is different. How treatment is different, I will tell you. Say initial concentration C 0, 0, C minus C alpha, C alpha, C alpha. Okay. For this we can write Ka1. Ka1 is equal to what? Concentration H ion, concentration of HS minus over concentration H2S. So equilibrium, writing equilibrium and writing expression is very important in this topic. You must be very comfortable with these things, otherwise you cannot solve question. It is like free body diagram. Okay, free body diagram in physics. As you draw FBD in physics, similarly in chemistry we write equilibrium. If we don't write equilibrium, then it becomes very difficult for us. Is it clear to everybody? So you must be very comfortable to write such equilibrium. So first ionization already has been done. Now second ionization again we can write, but I will not write concentrations here because there is a issue. So there is a problem. I can write H plus again S2 minus for Ka2, then I can write concentration HS minus. Okay, from chemical equilibrium knowledge, if we add them, then we will get final equilibrium, that is H2S changes to 2H plus plus S2 minus. We call it Ka net overall. Ka net, Ka overall. That is basically equal to what? Ka1 into Ka2. Got it? Another important information, Ka1 is very, very large than Ka2. Basically very, very large, don't use it. Ka1 will be greater than Ka2. Okay? Diprotic case. Logic is very simple. It is neutral species. It can liberate proton easily, but it is already negative charge species. Negative charge species means scarcity of positive charge. That's why it is negative charge. So if you want to make it lose a proton, then it will be difficult. So second ionization is difficult. Okay. So what we call only first ionization is significant. Here again there is a catch. That same thing, Ka1 10 to the power minus 2, 10 to the power minus 3 become a problem for us. That's why I didn't write the second expression. Got it? First expression is okay, but if you want to write second expression in terms of concentration, then there is a problem. You have to decide with the help of K1 itself whether I should go for quadratic equation for K1 or not. Are you getting me or not? The value of K will decide, K1 will decide whether I should use approximation here or I have to go for quadratic equation. Okay. So by carefully watching the value of K1, you can decide whether we can go for approximation or not. So every time 10 to the power minus 2, 10 to the power minus 3 become risky, and minus 4, minus 5, you can use this approximation, there is no problem. Only first ionization is significant. Third thing is anion concentration. Anion concentration is significant from first ionization only. So these are the two important key points that you have to remember. Important. Here I can put a mark, caution, danger sign. So we can put some fun side, khopri, that is a head, and two bones are there like this, danger sign. Danger sign is what? Ka1, nearly 10 to the power minus 2, 10 to the power minus 3. It is danger. Okay. We have to go for quadratic solution for the first step only. Then we can decide what are the concentration for the second step. Understood? So now I am erasing it. I think sufficient time is given to note it down. 32 minutes already passed. Half an hour. Damn it. Okay. So I can now erase these things. Board is small and shaky. But much better than the classroom boards. Now we come for triprotic. So suppose we take example of H3PO4. It will ionize in 3 steps. H plus H2PO4 minus. Anybody can name the ion? Dihydrogen phosphate. You can pause the video and you can listen it. Dihydrogen phosphate. Why dihydrogen? Because remaining 2 hydrogen are ionizable. Why dihydrogen? Because remaining 2 hydrogen are ionizable. We call it K1, first ionization. Second, H2PO4 minus changes to H plus HPO4 2 minus. Now it is K2, second ionization constant. Now the name of this species will be what? Monohydrogen phosphate. Third species, HPO4 2 minus, finally convert to H plus ion and phosphate ion. This is step number 3, Ka3. Okay, first ionization, second ionization, third ionization, and you can anytime add it. So add, it become what? H3PO4 reversibly changes to 3H plus. Previously it was 2H plus. Now because that was diprotic, it is triprotic. So by the number of proton you can decide what is the proticity or what is the basicity? PO4 3 minus. Again same thing. Ka net will be basically what? That is equal to Ka1 into Ka2 into Ka3. Got it? Here to remember, Ka1 is greater than Ka2 is very smaller than Ka3. This is important. And remaining 2 points will be same. What are those points? Only first ionization is significant. Got it? Second and third ionization are insignificant. That's why proton contribution, this proton contribution is by only first step. So whatever is the significant H ion you are getting, that will be from the first step only. Got it? So similar treatment you can do with the base which liberate 2 OH ion and which liberate 3 OH ion. Got it? Weak base liberating 2 OH ion and weak base liberating 3 OH ion, or capturing 2 proton or capturing 3 proton. Got it? Base has to either liberate OH ion or it can capture the proton. So basically we are following both the concept, Arrhenius concept as well as Lewis. We will not follow, we will follow Bronsted and Lowry, BL and Bronsted and Lowry concept, B and L concept. Lewis is basically medium independent. So these theory can be used in aqueous medium, and ionic equilibrium is basically all about aqueous medium. All the electrolytes, either they are strong or weak, they present in aqueous solution. Got it now? So now come to the numerical part. How to solve the numerical? Quickly I will solve three numerical and finish the video. It's enough for today. So first numerical I will solve. Calculate H ion concentration and pH. You know what is pH, everybody? pH is negative log of whatever H ion concentration. Okay, this is pH. One more thing you can recall, that is Kw is equal to concentration H ion into concentration OH ion. These things are very important, key points. We call it ionic product of water. Ionic product of water. Ionic product of water. If you are facing the problem in the properties of water, I can include in the next video. Okay, so I am assuming that you know these things. At 25 degrees Celsius, Kw is 10 to the power minus 14. So it is a self-understood condition. In ionic equilibrium, the temperature is 25 if it is not given. If we change temperature, or temperature is other than 25 degrees Celsius, then there will be a lot of problem. All the constants will change because these are equilibrium constant and they depend on temperature. Okay, so most of the time all the reactions are endothermic in nature. So basically weak acid, weak base, and even Kw, it is also endothermic in nature. So if you increase the temperature, these values will increase. Ka, weak acid increase, Kb, weak base increase, Kw, water is a feebly ionized, very weak electrolyte. So it will also increase by increasing temperature. Okay. One misconception, even some teachers have this misconception. So I will tell you what is that misconception. Maximum concentration of H ion greater than, less than equal to 1 molar. Okay, so maximum concentration is basically 1 molar. The H ion in any solution cannot be more than 1 molar. Similarly, OH ion in any solution cannot be greater than 1 molar. Maximum concentration of H ion could be 1 molar and OH ion maximum concentration could be 1 molar. 2 molar, 1.5 molar, 3 molar, these things are nonsense. Imagination, hypothesis. In real practice, such thing cannot happen. And chemistry is all about practical approach. not some imaginary thing. Okay. So calculate HIN and pH. I will take 3 examples quickly. First, any weak acid HA concentration is given 10 to the power minus 2 molar. Ka is given 10 to the power minus 2. Now you can understand it is a case of what? Risky situation. So we can deal it. Okay. So you can do it in homework and report me answer in the comment. Okay, I forgot that thing. Comment, like, share, subscribe, CND. Got it? Comment, like, subscribe, CND. So I'll give you hint, and rest you will do. HA changes to H plus A minus, K value is given 10 to the power minus 2, initial concentration 10 to the power minus 2, 0, 0, say 10 to the power minus 2 minus X. Don't go for that alpha sheet, not required. X, okay? But we know this K is 10 to the power minus 2, so we cannot neglect this X with respect to this, okay? Now put the value, get the answer. So 10 to the power minus 2 must be equal to X square upon 10 to the power minus 2 minus X. Solve quadratic. Okay. So report the pH and HIN concentration in comment. Or you can also ask, if you are watching this video, you can also ask this problem in the working hour. Okay. So these problems are you have given in the video. So we have solved it. Check the answer please. That we can do. Done. So A problem. I'm not erasing. Okay, I'm erasing everything now. Enough time is given. So now I can ask a question. I have given you the information that maximum HIN could be 1 molar, maximum OHIN could be 1 molar. If I am not changing temperature, what is the minimum HIN? What is the minimum OHIN? So that is again very obvious. Okay. So minimum HIN concentration could be what? Minimum HIN concentration could be 10 to the power minus 14 molar. And minimum OHIN concentration could be 10 to the power minus 14 molar. Got it? Or every time, don't forget it, Kw is equal to what? HIN into OHIN. You cannot change this equilibrium constant because this Kw, T constant, Kw constant. Got it? Okay. So if you increase the HIN, obviously OHIN will decrease and the product remains same, 10 to the power minus 14. Okay. So that's why maximum HIN is 1 molar, so minimum OHIN is 10 to the power minus 14 molar. Maximum OHIN is 1 molar, so minimum HIN is 10 to the power minus 14 molar. So they keep on swinging between these two limits. Okay. In any solution, if T is constant, the product cannot be more than Kw. It is a truth, fundamental truth. Okay. 10 to the power minus 14 is temperature dependent thing. Suppose I write like this: 10 to the power minus 14 is equal to HIN and OHIN. This is true only at 25 degrees Celsius, and this is a fundamental truth. Whatever is the temperature, we are not concerned, but this statement is true for every temperature, but this statement is only true for 25 degrees Celsius. Got it? The importance of temperature. So now this question is answered and you understood the concept also. So we can go for second problem quickly. I want to finish in 40 minutes. B. Second question is, say H2X and Ka1 10 to the power minus 5, it is 0.1 molar, and Ka2 is 10 to the power minus 8. Got it? How to solve this question? Again same, HIN and pH. Or suppose they are asking something else, you can do that also, but the tagline remain same always. So here the treatment will be like this: H2X will ionize like this, H plus, HX minus. The K1 is basically 10 to the power minus 5. So we can do approximation directly. This is 0.1 molar. So these two X, okay, or I can minus X. So these are same. So X is basically equal to root over K1 into C. Got it? So now we can solve the value. This value will be 10 to the power minus 5 into C is what? 0.1. That is 10 to the power minus 3 molar. Got it? This is the first ionization. Okay? Second ionization. HX minus changes to H plus X2 minus. The constant is now Ka2. That is 10 to the power minus 8. It is smaller than this. 10 to the power minus 5, 10 to the power minus 8. So it is smaller than this. So this forward reaction is negligible as compared to first. Such things are very important in ionic equilibrium. If you don't do this, you will face a lot of problem. Okay? So Hx minus we already know, that is Xx. So we can put directly here 10 to the power minus 3. Hn is already X, 10 to the power minus 3. We don't know this because it is appeared in the second ionization step. Now 10 to the power minus 3 minus y, because X I have already used. This is 10 to the power minus 3 plus y. Y plus y, forward reaction. It will decrease, it will increase. Already 10 to the power minus 3 is there, and this become y. Now do the approximation. What approximation? Y is very, very smaller than 10 to the power minus 3 molar. This approximation can be done. So roughly it is what? 10 to the power minus 3 molar. It is also 10 to the power minus 3 molar, and it is y. Don't neglect it, because neglecting thing always done with respect to somebody. Are you getting me or not? A girl can neglect you when there are two or more boys. If you are the single boy, then obviously you have understood. Okay? So neglect is basically comparison. So here we have nothing to compare. That's why it is not neglected. Here y is compared with minus 3. Y is compared 10 to the power minus 3. That's why it is neglected. Understood? Now rest is very simple. Put the value, get the answer. Okay? You can calculate this value. But Hin is basically what? I have told you in the points. Whatever Hin we got, that is from the first ionization only. Suppose you want to calculate this value, then you can do the calculation. Okay? So what calculation you will do? I will explain once again. For the slow learners, so what we can do? K2 10 to the power minus 8 must be equal to 10 to the power minus 3 into y upon 10 to the power minus 3. These are cancelled. So y is basically 10 to the power minus 8. Got it? Now you can easily understand y is what? 10 to the power minus 8. 10 to the power minus 8 is negligible as compared to 10 to the power minus 3. Got it, everybody? Now in this question there is a misconception or common mistake done by student. What is that mistake? I will tell you. Can I erase it now? Done. I am again assuming whatever I am doing with the acid, similar thing you can do with the base by simply replacing the Ka to Kb, and calculation concepts are same. So what is the mistake generally people do? Suppose I change the question. I will take another question. Calculate x2 minus concentration in 0.1 molar H2X if Hn concentration is 10 to the power minus 3 molar. This is a common mistake. So by any other source, whatever information given here, we have to solve the question within the limits. So basically we can write the complete equilibrium. So H2X we can write K1, K2 thing are same. So H2X we can write 2H plus X2 minus. Got it? Now we have to use K net. K net is basically 10 to the power minus 5 into 10 to the power minus 8. That is 10 to the power minus 13. Got it? Now, this is basically what? 0.1 molar. He has given already. H ion is fixed, given 10 to the power minus 3 molar. You cannot change it. What he is asking? X. Okay? So, what we can do? We can write K net. 10 to the power minus 13 is equal to 10 to the power minus 3 whole square. Understood? Stoichiometry is 2. Stoichiometry square into concentration of X2 minus. So, this is the common mistake done by students. Okay? Don't do it. Rest is calculation. They follow 2 steps, not required, because H ion is already given. Okay. In this problem, if you do the reverse engineering, some issues may be there, but I can justify them. I can say it is a buffered solution where H ion is constant. Why it is buffered? Leave it. Okay. The thing is, okay, reverse engineering means somebody may put, we can write K1. I'll show you. Just wait. Done. So somebody want to do reverse engineering for this question. Then they can say, sir, what nonsense you are teaching. So what is the reverse engineering? I'll tell you. Reverse engineering is this: H2x changing to H plus and Hx minus, and K1 is basically 10 to the power minus 5. They do reverse engineering like this. This is 0.1 molar. This is given 10 to the power minus 3. So this Hx, I don't know what I can calculate. Yes, I can calculate. How I can calculate? This is 0.1 molar. The K is 10 to the power minus 5. Approximations valid. It is very, very less than 10 to the power minus 5. Approximations valid. So we don't have to go for XX thing. Understood or not? Not required. Because anyway you are going to neglect them. If you take it, you can neglect them. Okay? Now, if this H ion 10 to the power minus 3 is constant, then there could be a problem in thinking. What problem may arise? That you may think, let me calculate this H ion and I will add this H ion. Okay? So suppose you want to calculate H ion. Follow me. Suppose you want to calculate H ion, then H ion will be what? Under root K into K1 into C. That is equal to 10 to the power minus 3 molar. Got it? So somebody may say, sir, it is 10 to the power minus 3 already, and it is given in the question 10 to the power minus 3 already. Then how this is possible? It must be 2 into 10 to the power minus 3. So such reverse engineering sometime may be harmful. Okay? Go with the data. What is given in the question, follow that only. Reverse engineering sometime not useful. It may lead to confusion. Okay, third problem, last problem, and end of the video. Third problem, it will be very simple. Basically, it is homework thing. So suppose I have, see example, H3x. So Ka1 is 10 to the power minus 5, K2 10 to the power minus 8, and K3 10 to the power minus 12. Okay? I have taken very safe side. The values I have taken to avoid any confusion. If you do the reverse engineering, there will be no confusion. Okay? So all things, basically what you have to do, calculate. I will erase this now. Example C. Calculate H ion concentration, comma, Hx minus concentration, comma, and X3 minus concentration and pH. Okay, so it is homework basically. Do it. Like చేయండి, comment చేయండి, share and subscribe చేయండి. Thank you very much. Bye.